Hello everybody, this is Mr. McAllen, and today we're going to talk about how to graph basic graphs of sine and cosine. So we're going to start off by using the unit circle, and we're going to plot quadrantal angles in radians. So let's just start off on the unit circle. We're going to plot these coordinate points, and I want you to remember that from the unit circle, when we plot these coordinate points, that the x value corresponds to the cosine of the angle. So right here theta would equal 0 radians, and at this point here we have the coordinate 0, 1, and that angle theta would equal pi over 2 radians. At this angle over here theta would equal 3 pi would equal pi radians, and at this angle theta would equal 3 pi over 2 radians. When we finally get the circle to complete a full revolution, we're back at theta equaling 2 pi radians. So the coordinates of these points would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Remember that the x-coordinate is a cosine ratio and the y-coordinate is the sine ratio. So what we're going to do is we're going to plot y equals cosine first. Remember, now when I say y, that's the y-axis, and this is the theta axis. So we're going to simply plot at each quadrantal value, we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. And we have 0 here, and the function varies between, if you look at the x values, it varies between 1 and negative 1. Okay, so we're going to first, when we're at 0 radians, we're going to plot the point 1. When we're at pi over 2, we're going to be at 0. When we're at pi radians, we're going to be at negative 1. When we're at 3 pi over 2, we're going to be back to 0, and then when we finally get all the way around the circle, we're going to be at 0 at 1 unit. So we draw our cosine function in, and remember it has this curvature. It's frowning, then it's smiling, and then frowning again. And that curvature is created by, as the x-coordinate processes around the circle, it gradually changes, goes through its the motion from 1 to negative 1. When we come over here and we look at the sine function, we're going to graph that against theta as well. And again, the values, the sine value will range from 1 to negative 1. And if you look at the x-coordinate, and I'll just highlight it so you can just focus on the y-coordinate, okay, you can see the precession that it makes. It goes, in this case, from 0 to 1 to 0 to negative 1. So it starts at 0, it goes to a value of 1, it returns to 0, then it hits negative 1 and returns back to 0. And I want to put the radian values on there, so these radian values are pi over 2, pi, 3 pi over 2, and 2 pi. And this function would have the same type of curve as a cosine function. It just appears as if it's been shifted over a bit. Now, this function, if we continue to rotate around, the curve would continue on. So if you want to ever increase or add more periods to this function, you would just keep incrementing by pi over 2. So I'll just increment this by pi over 2. So at 2 pi, that's really 4 pi over 2. So the next one is 5 pi over 2, then 6 pi over 2, 7 pi over 2, and 8 pi over 2. And hopefully you can simplify those numbers. And I'll just keep following the progression. It goes down to 0, negative 1, 0, and 1. And you would just add in your next cycle. The same would be true if we were going to do that with the sine function. Let's take a look at one other example. Now we have a different type of sine function or cosine function. We have a cosine function where we are multiplying it by the value 3. So what it would do to these values is it would multiply them by a multiple of 3. So now our function would go from 3 to negative 3. So we simply draw in the same radian values. So we have pi over 2. I'm going to zoom in a bit. Let's get pi over 2. We have pi, 3 pi over 2, and 2 pi. And the function before varied from 1 to negative 1, so cosine, it's going to start at 3 in this case, because 3 times a 1 value is 3. It's going to go to 0. Then it's going to follow the progression that we had before. So this is just going to be a stretched out version of the one we did earlier. It just is stretched by, so this 3 is actually called the amplitude, and it's responsible for a vertical stretch. And the sine function would respond the same way. I'm going to just draw that in green again, and I'll draw my radian values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the sine function, remember, it started at 0, and it went up to a 3 value and down to a negative 3 value. So we would just follow the progression on the quadrantal values, and we get a more stretched out version of sine, because the amplitude is 3 units. Now let's switch to another objective which we can accomplish quickly. It's how to determine the amplitude, period, phase shift, and vertical shift for any sine or cosine function. And this is simply reading values off of the sine function or the cosine function. And notice I have them labeled as A, B, C, and D. These are just numbers or tuning values that you can add to your sine function so you can change its appearance. In the earlier example, we tuned the value A to be 3, and that caused our sine function to change from a function that varied between 1 and negative 1 to where it varied between 3 and negative 3. And this is just a quick sketch, but we had our 5 quadrantal values. We had 0, pi over 2, pi, 3 pi over 2, and 2 pi. What we want to talk about now is we want to mention what these other coefficients mean and how to determine what they are. In the next video, I'll show how they change the graph that we're working with. So in the first example, the problem says, for the function y equals 3 sine of 2x minus pi minus 1, it asks us for the amplitude, frequency, phase shift, and vertical shift. So the a value would be 3. That means the function would move up and down 3 units from its middle. The frequency is 2. The phase angle is negative pi, and the vertical shift would be negative 1. That's just looking at the values as displayed by the typical function. Let's look at some more examples. Here we have a chart, and the chart has a variety of different trig functions, all with different a, b, c, and d values. Remember, if the coefficient a doesn't seem to be there, the a value would be 1. So for example, in this function, the amplitude is 1. There's a b value, there's a multiple of 1 there, so the frequency would equal 1 in that case. There are no parentheses. Now if there were parentheses, you would say 1 is the c value, but since there are no parentheses, you would say that we have no c value, and which is the c value is called the phase angle again, and the d value, or the vertical shift, is equal to 1. I want you to try all of the other problems on here, and then when I resume the video, I'll have the answers posted. Okay, so I'm back, and I went through the other 3, and I left 2 for us to do together. So the amplitude in the first one is 1, frequency is 1, phase angle, which is, because you see the parentheses, is 1 and the vertical shift is 0. If you look through the other two problems, you can see that in both cases the amplitude is 3. Now the reason why I didn't worry about the negative is because the negative just tells me that the sine function, instead of it moving up at first, it moves down at first. So we still call the amplitude a 3 value, because all the amplitude describes is how far up and down the function moves from the midline. The last problems here, I'm going to just say, work with you, is the amplitude in this one is going to equal 2. The phase angle, the frequency is equal to 1. The phase angle, I'll just abbreviate PA, is equal to pi, or negative pi, and the vertical shift, which is the d value, is equal to 0. The last problem, the amplitude is equal to 2. The frequency, which is known as the b value, is equal to 2. The phase angle, which is the c value, is equal to negative pi, and the vertical shift is equal to 0. Hopefully this video helps you in understanding some of the basics of graphing the sine and cosine function, and my next video will talk about how we graph these more complicated functions, but first you should understand how we graph the basic sine and cosine. Please like this video or subscribe this channel, or